The derivative can be thought of in a few ways. The first is the slope of the tangent line at a single point. The second is the instantaneous rate of change, also at a single point. Another is the increase or decrease in a function value for every one increase in x, or the input. Another is marginal change. Now, when we talk about marginal cost, revenue, or profit, that is the amount of money made or spent for producing or selling one extra item. So in other words, if you were already producing 200 items, the f prime of 200, or the first derivative at 200, is how much it would be for the 201st item. So how you interpret the derivative will depend on what they're asking for. Slope of tangent line, rate of change, increase or decrease, marginal change. Now, when you're interpreting, there's certain things that we don't want to forget. We don't want to forget the time frame, what it is that we are studying, in other words, the function value, if it will increase or decrease, and by how much. Now, by how much, that is our derivative. And then, of course, the units of that derivative. So there's really 5 things we're looking for when we are interpreting a derivative. So in example G, they're asking about instantaneous rate of change. The total inmate population in the Federal Bureau of Prisons can be modeled by f of t equals 1/4 t squared plus 9/25 t plus 24.5, where t is in between 1 and 17 with the endpoints included. They also state where t is the number of years since 1979, and f of t represents the total inmate population in thousands. So those are 2 very important pieces of information, t since 1979, and f of t is the inmate population in thousands. So they're asking us to find and interpret f prime of 11. So let's first determine what the derivative is. F prime of x, you take each of these terms and take the derivative. This first term, we multiply the 1/4 by 2. So that gives us 2/4 or 1/2 t to the 2 minus 1, which would just be 1, plus the coefficient of 9/25, and then again plus 0, since that last term is a constant. Now we want to plug in the number 11. For this example, we're going to go ahead and round, since we're talking about a population in thousands. So it makes it a little bit easier to multiply that decimal by thousands. So keep in mind that we were told that t is the number of years after 1979. So if t is 11, that means we're 1970, I won't say it for me. 1979 plus 11 will give us the year 1990. Also, that f of t is the number of inmates in thousands. So that 5.86, as far as the derivative, if we multiply it by 1,000, would be 5,860. But for the f prime of t, remember that's a slope. So this is the number of inmates per t is in years. So our interpretation would be in 1990, that's our time frame, the number of inmates, that is what we're studying, that's our output value, our focus, increased. Now, how did we know it increased? Because our derivative is positive. We have a positive slope. Positive slopes go upward. So the number of inmates increased by 5,860. That was the derivative that we found, and our units, inmates per year. In our next example, it says the cost in dollars of producing X units of a certain commodity is C of X equals 5,000 plus 10X plus 0.05X squared. They want to find and interpret the marginal cost at a production level of 75. So the fact that they're asking for a marginal cost, that is our hint that we're looking for the first derivative. So let's find the first derivative, and then we'll plug in our 75. So the derivative of a constant of 5,000 is 0. 10x would just be 10. And then multiplying the 0.05 by the 2 would give us 0.10. And then x to the first. So again, simplifying that, we get 10 plus 0.10x. Now we want it at a production level of 75. Now, how did we know that this 75 is our x? Because we're producing x units, a production level of 75. We're producing 75. So if we plug in 75 in for our x, now we can write this as C prime. You may also see it as MC of 75. And that MC is standing for marginal cost. So to interpret this, we need our time frame. Well, in this case, we're not actually talking about time, but we're talking about when. We are producing 75 units. So we would say at a production level of 75, it would cost $17.50. Keep in mind, we got 17.5. They told us the cost was in dollars, but not hundreds of dollars or thousands of dollars. So we take it at face value. But what does marginal cost mean? At a production level of 75, it would cost $17.50 to produce the 76th unit. So all of that is the marginal interpretation. Now here's just a generic example where they already have the derivative. F prime of 10 equals negative 200. This interpretation would just be if our input value changes from, now it's already at 10, and remember the definition of a derivative, it talks about the increase or decrease in y for every one increase in x. So if our input, again, x, changes from 10 to 11, our output will also change, but will it increase or decrease? Notice here, the derivative is negative. So that tells us that our output value will decrease by 200 units.